you should have something on your computer that looks like this. So it's called Anaconda Navigator. I have the download link and some instructions on how to install are on Moodle. And it consists of different parts. So these are just the basic parts. So we will be using this one. It's called Jupyter Notebook. And we will first be using Spyder. So Spyder, okay, maybe I can do a little poll before we go into the real matter. So I'm going to launch this poll. So just to know, okay, so you should see these questions. So if you have any coding experience, and if so...
What does a lot mean?
Sorry? Not a lot. Well, I don't know, maybe you've used it in a master project, or you spent several weeks using it, then I would say a lot. Okay, I'm not saying you should have 5 years of experience, but like if I tell you solve a differential equation using a code, that you would be able to do it. So that would be a lot, let's say.
Okay.
Okay, so there are 3 questions, right? Most of you are seeing it. I'll give you a minute.
And for the second question, it's not multiple choice?
Oh, sorry. Yeah. So if you have, okay. Apparently not. So just take the one that...
I pick the one I like best.
Sure. Okay. It's just to get an idea, it's typically the people that are in chem informatics. They, of course, are more inclined to have a, coding background, I guess. And the others not. Okay, so most people voted. Wow, 0 people MATLAB. That's interesting.
So of course we also MATLAB, but it's quite hard for me at least.
It's quite hard. Okay, so I'll try to make it easier than, I don't know who was teaching you MATLAB. Okay, so some people have not managed to install the software. So maybe we can do after the class some smaller group where we look with the people. Okay, so seems like 3 people that couldn't install. Okay, so let's end this. Share results. Okay, so most people have no experience or a bit. And the people that do have mostly Python. Well, that's good. Well, okay. And 90% at least knows the kind of basic principle that coding is based on. Okay, so thanks for sharing that. Okay, let me close that. Okay, so like I said, the first part will be kind of a very simple demonstrator. So if you don't have Anaconda installed yet, it's not a huge problem. Yet let's say in the second session, it would be nice if everyone has it working so we can try some things together. Okay, so basically you have your navigator, you press launch on Spyder, and it should open a new window. So again, if it doesn't work yet for you, don't worry, because I'm first going to spend today on trying to, let me see, let me do it like that, on explaining you the basics of this kind of software. So so Python is a coding language, right? And a lot of data scientists, scientists in general, are using Python well, as a code to do research. So it's increasingly popular. And let me just, okay, let me just mute. Sorry, some people are not muted. Okay, there we go. So the Spyder, so this window here, is basically an implementation of Python, but made easier to do research. And it looks very similar to MATLAB. So if you have MATLAB, you also have you have a console. So on the bottom right, you have a console where it's kind of a command line where you can execute things. So, you know, if I type 1 + 1 or 1 + 2, I get 3. Okay, so you can use it as a little calculator. You have another window here, which has, by default, it has variables. We'll see what those are. And then you have on the left, you typically have a scripting window, which we will use a lot later. So for the moment, I'm going to make my console a bit bigger because we're going to start in the console. So in the console, if you type something and then you hit enter, it executes that line. So again, so if I type 2 + 4, hit enter, it will execute only that line and it will give an output, which is 6. Right? So once we later we'll see if we go to a bit longer code, you want to first write a number of lines in a script and then you want to execute that whole script, right? So one note, maybe I can show you on Moodle. So 1 second. I put it as student view. So I put a very nice class. Okay, so let's go on Moodle. All right, so it says here, optional self-paced edX Python course. And so this one is incredibly good. Let me just open the website. Right, so it's a course. It's open now, basically, and you can enroll. And once you enroll, you can see videos by this professor from Harvard. It's if you want to get a certificate, you need to pay, but you actually don't need to pay. You can just do the free version. You won't get a certificate, but okay. And it has, let's say, today I will do a very kind of overall introduction. But if you want to go slower in more detail, I really recommend this course. It's super good. And the first 3 weeks, or the first 1 to 2 weeks and a bit of week 3, have basically all the basics that you need to really get Python going. So if you think after today it was too fast, or too slow, that's also possible. You can do this self-paced course. It's really, really good. Okay, so with that, okay, let me go back to my Spyder. Okay, so Spyder. One thing you have to know, so Python was originally not designed to do scientific, things. So even the basic code doesn't know a lot of things like, what is pi, the number pi, or what is the square root. So that's a bit the weird thing when you start with coding. If you go to C++ or any other language, then it doesn't know many of the things that you would think that are very trivial for us in simple mathematics. But there's a solution for that. There are so-called libraries or modules that you can import into Python, and they will give you a much broader range of tools that are needed. So for example, there's one that's called math. So you see that the color changes, right? I do import, then math, and I hit enter. And now I've loaded this library, which it pulls from the internet, and now I can use it. So if I type math.py, it knows pi. Okay, so that's cool. If I do math.py, square root of 10, for example, it gives me the square root of 10. So they're very, like I said, very easy modules that you can use. And for example, math.sine or other things, you can actually use those libraries. But the math library is very simple and a bit limited. So there's a more powerful library, which is called NumPy. And so you can do import NumPy as NP. So what is this doing? It's importing the library that's called NumPy, but then if I use a function in that library, I would have to type every time NumPy and then dot something. Just like if I want to use pi, which is in the math library, I have to type math.py. But I can import it in a different way and I can rename it. So this as NP, I'm just saying, okay, from now on in my code, I can use this library NumPy as NP. So I just have to type NP dot, and then I can use functions that are within the NumPy library. Okay, so that is very, very basic. I think you can type also dir, which you can put some kind of function. So if I put dir np, I think this works. It will give you a list of all the functions that are in NumPy, which are a gigantic amount. But for example, log or 10log or 2log are defined in the NumPy library. I mean, we're clearly not going to go through all of these, but like things like the exponential, which might be useful, counting. Okay, so if you want information on a certain library, you can just type dir and then the name of the library, and it will give you all the possible functions. And there are also help files available. If you go online and you type, NumPy Python and then, log, it will give you a lot of information and examples of people that are using the same module as you are. So that's a very valuable resource to get information. Okay, so first kind of section. Oh, maybe before we start, a good thing to learn is how to delete stuff. So if you want to start from 0, you can type clear all, and it will delete your console. So we're back to 0, and you can type reset, and then it says, "Are you sure?" And then you say yes, and it will delete this in this variable explorer. You see that it has deleted now all the variables that were here. Okay, so let's start from this clean slate, and we go with the simplest example. Okay, so we said, you can just do 1 + 1, 2 × 3, so multiplication, to the power. So if I want to do 2 to the power 2, you use this double multiplication. Okay, so 2 to the power 2 is 4, 2 to the power 3 is 8, right? So that's to the power, which in MATLAB, they use like 2 to the power 3. Doesn't work here, see? So to the power is 2 times the asterisks. 15 divided by 2, okay, that's the normal division. There is another one, which is 2 dashes. And this one is called integral division. So it divides and then it rounds off to the nearest integer. What is an integer? An integer is a whole number. So 0, 1, 2, 3, 4. Okay. So, and it rounds down apparently to the nearest integer down. Okay, so 7. Not very useful for us, but it exists. An underscore can be useful. This reuses the last output. So I did 15 / 2, I get 7. If I type underscore, it will use the same again. So if I say underscore times 2, it will say 14. And if I repeat that, it takes the last answer, and you just keep that, using that as an input for the next line. That can be interesting if you want to use a factorial. I don't know if you know what that is, but that's in the math library. So if you do math.factorial and then say 3, well, okay, I did reset, so I have to do again import math. Every time you reset, it also deletes all the libraries. Not very useful, but okay. So 3 factorial is 3 times 2 times 1 is 6. Okay, those are numbers. Then there's something weird maybe in data types. For example, I can now assign a variable to a certain value. Let's say I say a equals 2. You see in this top window here in this variable explorer, you see now a variable that is called a, and the type is integer, right? So it's a whole number, and it has one number in this variable, and the value of that number is 2. A bit weird, because if I type b equals 2.0, you would think it's the same, right? I mean, how is 2 different from 2.0? But 2 is an integer, and 2.0 is interpreted as a float. Okay, so sorry for floating so many of these types here, but you will see later what that means. But a float is basically a long array of numbers. So I can have many digits behind the comma, which are stored in a float, which is basically a longer number than an integer. Okay, this will be important later on. You'll see how that is important. Another super important thing that is used in coding, so basically all computer code, like machine code, is based on logic. And the most famous one is so-called, I'll just type it, Boolean logic. Okay, so if you type this pound, it will treat it as a comment. So this line will not be executed, right? It's just a comment in the code, which it's the same as here, for example. In my script, by default, it puts 2 lines with this pound sign, which are then gray. And if you want to put a longer comment, you can put this triple quotes, and then everything until the next triple quotes is again comments, so it's not executed. Okay, so Boolean logic is basically based on true and false, right? So if I type true, it gives us output true, and I say false, false. Okay, and you're like, what is this? So now we can do a logical test. We ask the computer a question, and it will look at it, and it will give us an answer if our question is right or wrong. So a very simple question. We ask, is 2 smaller than 4? Right? I don't have to put a question mark. I just write 2 smaller than 4, and then I hit enter, and it says true, because yes, 2 is smaller than 4. If I say 2 is larger than 4, it will say false, because 2 is not larger than 4, right? So the Python gives you as an output a Boolean statement, which is true or false. Okay, so what are the different logic operators? So one is question 2 is smaller or equal to 4, right? So this is smaller than or equal to. Yes, that is true. Now comes a very weird one. I say 2 equals 2, right? And it says true. Okay. But now if I say, for example, 2.0 equals 2, also true. Okay, so this is really looking at the numerical values of this number, and it's saying that it's true. The last one I want to show you is not true, so that is exclamation equals 2. So this means we ask, is 2 not equal to 2? And it says false, because they are the same. Okay. A little bit more difficult. So we can say 2.2,3. So now I'm making an array, right? And I say 2,3. So this is an array equals 2,3. So what do you think? 2,3 is equal to 2,3? Yes. Kind of logically, it seems like that. Now I say 2,3 is 2,3. So is looks at different aspects of this number, and it will say false. So let's look at that. So if we say C equals 2.3, it says C is a list, and it has 2 values in it, and the values are 2, 3. So 2 and 3 are in a list. Okay. So lists are a different type of data. So we already saw integer, we saw float, so 2 comma something, and lists is a way to store different numbers together. But if we use this is operator, it's actually looking at the exact object. And this object, in this case, if I call 2,3, it stores it somewhere in the memory. And if I say, is this the same as another one that I make, it's in different parts of the memory, which is why it's false. Okay, this is confusing. And for that reason, we will actually start using NumPy arrays instead of these lists. But okay, just to finish this off, okay, so we said before that 2.0 equals 2. This is true because it's looking at the value, right? But if I say 2.0 is 2, it will say false. Why? Because it looks at the okay, what's the difference between, right? Okay, so the second one, indeed, so this is the same example. If I look at 2.0, it is a float, whereas 2 is an integer. So if I type is, it also looks at the data type, and it will tell you that 2.0, because it's a float, is not the same as 2, which is an integer. I find this extremely confusing. When I started coding, I was like, who cares about these kind of things? But many times in your code, it will give some kind of error message, like, hey, this cannot be an integer, or this cannot be a float. So you have to keep that in mind when you start working on that. Okay. So sequences. Okay. Sequences. This is also something I find quite confusing in Python. Let's say we're going to make a list, and we're just going to call it numbers. And I'm going to put some numbers in it, 2, 6, 8, 10. Okay, so if I look in my little list here above, right, I see there's a new list, which is called numbers. It has 4 numbers in it, and the numbers are 2, 6, 8, 10. Okay, you can now call a certain value from that list. So if I want to say, I want to get the first value of numbers. So I say numbers 0, which is 2. So in Python, the first index of a list or an array is 0, which is confusing because in MATLAB, you start counting at 1, 2, 3, 4. And in Python, you start 0, 1, 2, 3. So if I look here again, numbers, and I say 3, it's the last one. It's 10. So 0, 1, 2, 3. Okay, so I'm kind of going through the indices of my list. And so the last one, so that's kind of useful. If I say numbers -1, that means the last index of your list. So you don't need to know how long your list is. In this case, you just say numbers -1. That's the last value of my list. And number 0 is the first one. Okay, so that's important to keep in mind. Okay, so you can extract. Okay, let's look at some things you can do with numbers. So let's say now we say numbers, which is a list, dot append. So we say, for example, append 12. Pop. Now we look in my list. We have numbers. Now we have 5 numbers in my list. And we have 2, 6, 8, 10, 12. Because I appended 12. This is a kind of useful command because let's say you're doing a calculation and you have a result and you want to store that result, you can just append it to a list, for example. Okay, some weird things about lists. So let's say we call, let's say list 2 is numbers plus numbers. Okay, what happens? Not what you would maybe mathematically expect. So it makes a new list, which is called list 2. And it just repeats the number. So I have 2, 6, 8, 10, 12, 2, 6, 8, 10, 12. So maybe not what you would expect when you, when you sum a list up, right? So later, when we go to NumPy arrays, it will behave more like mathematically. Like if I have a vector and I want to add it to a second vector, I will add, for example, each number of the same index to the same index. Okay, yeah, append is always in the last position, exactly. Okay, what else can you do? You can say numbers dot reverse. Okay, so let's see what happened to numbers. Well, nothing. Maybe I should store it in another. Okay, sorry, I forgot something. Numbers dot reverse, and I have to say reverse itself. Now we look. Okay, now we reversed the order of the original list. Okay, so what is important in numbers? Lists in Python, they are what is called mutable. That's a very fancy word for saying they can be changed. Right, we'll see another data type which is called immutable, so it cannot be changed. Okay, let's finish with the lists. So, for example, I can say sorted list. I'm making a new list where I'm going to sort the numbers. So I'm going to say sorted, and let's do list 2. That's longer. Okay, so I'm taking list 2, which is 6, 8, 10, 12, 2, 6, 8, 10, 12, and I'm going to sort them. Now I have a list that is called sorted list, which is 2, 2, 6, 6, 8, 8, 10, 10, 12, 12. Right? So you can sort values numerically. And an interesting and very useful command is len, which is length. So let's say length of numbers is 5. It's the same as this, what you can see here. The size is 5. So the length of this list is 5. That sometimes is useful when you're coding and you don't know exactly the length, but you want to use it somewhere else. Then you can actually sample the length before you continue. Okay, so that was lists. Let's move to another data type, which is a very weird one. It's called tuples. So sorry again for this jargon here at the beginning, but it's kind of important to understand these different data types because sometimes things don't work simply because the data type is wrong. Okay, let's make our first tuple, and it looks very similar to list, but we're going to use round brackets. You saw here I was using square brackets, right? So very important in coding is, you know, all the different types of brackets have different meanings. So you have to clearly separate that. So I say, for example, 3, 5, 1, 3, 5, 7, pop, and I go to my list here and I look, okay, we have a new variable, which is called t, and data is tuple, and it has size 4, and it has these values. So it looks very similar to a list, right? So a lot of things are the same. So if I want to know the length of t, it's 4. So that's very similar to a list. If I say t plus a list, plus another tuple, it would put them together. But if you look in my original value, it didn't update this value, right? So just this output temporarily is longer because I added another tuple. But the original tuple is what's called immutable. So that means it cannot be changed. So once you write the tuple, it's kind of a fixed number or a fixed list, right? So you cannot, you can still use it for other things, but you can not overwrite the original tuple. Okay, so the same thing if I say t 3. Oh, sorry, I should have done square brackets. So that means the 4th index of the tuple, right? 0, 1, 2, 3. So the last one, 7, is with index 3, right? So tuple t index 3, it gives you value 7. Okay, so then let's do an example. So it's called unpacking a tuple. Tuple. Okay, so let's say we have a variable x is 2.3 and we have y equals 3.6. Then we say, okay, we're going to make a coordinate. These are just names, right? You can write whatever name you want. And I'm going to pack my tuple. So I'm going to say x, comma, y. Right, so I'm going to store that in this coordinate. And if I want to know the data type, I can look here at the top. So it's tuple with 2 values, which are 2.3 and 3.6. But I can also write type coordinate, and it will say tuple. So I can also look up my data type using this type command. If I want to, let's say now, use these coordinates in another way, I can unpack my tuple. And so I can say C1, C2 is coordinate. Click. And I have now two values, C1, which is 2.3, C2, which is 3.6, which are float, right? So these are, again, numbers with some accuracy. So I unpacked my tuple. So it can be useful to use tuples to save something that you want to reuse all the time. Okay. Another very important function is called range. And so, for example, if you say range 5, it will go from 0 to 5. If you want to see what's in that range, you have to say list range 5. Okay, so what does it give you? 0, 1, 2, 3, 4. So it makes you, by default, it just starts at 0 and then it adds 1. Because often you have a code and you have, for example, a loop where you want to go around a number of times, and every time you want to go to a different row of an array, for example. So then you can make a statement and you can use this range value to make, instead of typing 0, 1, 2, 3, 4, you can use the range function, because if you do the same for 20 or for 100, for 5 you can still type it by hand, but once you go to 100 it starts becoming very long to type every time all this stuff, right? So the range function gives you an easy way to make, for example, a linear array. You can also make more difficult ranges, right? So for example, I say list range 1, 13, 2. So what will it do? It will start at 1, it will stop at 13, and it will have an increment of 2, right? So it does 1, 2, 1, 3, 5, 7, 9, 11. Okay. So by the way, I will put these notes again on Moodle, so you can rework them if you want once you install your version, or if you have it already, feel free to type along. Okay, so we'll go to statements. Okay, so statements are very important, and we're going to make our first little mini code already. Okay, so we have X and Y defined, right? So I'm going to say a kind of code where I use a statement. And the first statement I want to use is called the if statement. It's very powerful, okay? So the if statement, it's you say if a certain logical test is true, then you execute whatever code is coming after it, and otherwise you do something else. So if I say if X is larger than Y, colon, so this is very important. Now you have to put a colon here, otherwise your code will not work. And I type enter, and you see it indents. So it doesn't give you an output yet. It just goes to the next line. And on that next line, I'm going to define a small function that it's going to execute. So I say difference. This is just a variable that I define myself. I'll type some spaces. X minus Y. I press enter. It still didn't execute. Okay. And then I say print X is greater than Y. Oops. Okay, so that's just text, which appears in green. And now I just use the cursor to go left. all the way to the same level as here. So this, it will look, is this statement true? Yes, then I will execute these two. And otherwise, if this is not true, then I won't do this. But you can write also a statement, print, print, always printed. So this, because it's at the same indentation as the if statement, will always be executed. So only the indented part, so this one, will be executed if this statement is true. Okay, so let's execute that whole thing, and it says always printed. Okay, clearly because x is 2.3, it's not larger than 3.6, so this is false, and because it's false, it doesn't execute these two. If you press arrow up, it will just repeat what you typed before. So we can just, for example, flip this. Okay, and I go back to the end, type enter, and now it says x is greater than y. Oh, sorry, this was of course wrong. I should have updated this with x is smaller than y, but it shows you that this one is now executed, and it made this new variable, which is diff, which we define here, which is x minus y, and it's a float with that value. Okay, so maybe another interesting part is that you see that the typical float has a limited number accuracy, right? So it doesn't have that many zeros behind the comma. Usually enough, but there's another data type which is called float 64, which has much longer numbers. Okay, we'll come back to that. Okay, so other statements. So that was the if statement. There's also related to that. So there's elif and else. And so you use those typically together in the same arrangement. So for example, we write the code, we say if x is larger than y, enter. We're going to make a variable that we call absolute value, absval. This is just something we define. And we say x minus y. So we're making kind of a small function that's going to give us the absolute value of different numbers. So we say, if that's the case, then absval is x minus y. But then if it's not, we go to the same level, we say elif, so else if, so if it's not the case, you can, for example, say y is larger than x, then absval is y minus x. Okay. And then the last one is called else. Up. Absval is 0. So this is making a little function, right? That says if x is larger than y, and this is true, then I define absval as x minus y because x is larger than y. So I don't want to get a negative number because I want to get the absolute value. Then you say, well, if that's not true, then check else if. So if y is larger than x, this is true, then you do y minus x. And if none of these is true, else you say, okay, this is absolute value 0. Okay, so we did that, and we look if we have absolute value, yes, and we have, like we expected, a positive value, 1.3, because, let's look again, x is 2.3, y is 3.6. So if x is larger than y, which it's not, right? So this is false. So it skips this line. Then it says, well, in that case, if that is not true, is then maybe y larger than x? And it looks yes, because y is 3.6 and x is 2.3. So we say absolute value is y minus x. Okay, nice. So else it doesn't need this one because this one is true. Okay, is this understandable? Is this too complicated? We'll go through some examples later to see how that works. So that's if statement, else if, and else. Okay, very powerful. Another thing which we're going to use a lot is the for loop. Okay, so the for loop, for example, for x in range 10, colon, right? Otherwise it will not execute. Print x. So it will go to this code. It will go to the first line and it will say for a value that we randomly call x. This can be, you know, whatever you want, a, b, x, little dog. I mean, whatever you want. In range 10. So we saw before range 10 will give you a list 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so for the first value in that list, I'm going to go to the second line and I say print x. Then it goes back to the first line. For the second one in the list, I'm going to execute the second line, and that is print. Then it goes back for the third value in this list, print x. So it's a for loop because it's looping the same code 10 times, right? So let's see what it looks like. Print, and I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like we expect. Because if we look, list range 10. Oh, I forgot a bracket. There we go. Which is this list, right? Is everyone understanding that? That's kind of a very fundamental principle of for loops. So you usually define a list and you can, let's say if you want to run the same code 10 times for some reason, you can do it using a for loop. But like I said again, you can type anything. You can say for puppy in range 10, print puppy, right? And this will give you exactly the same result because you can assign whatever name for each of the indices in this list. Okay, I hope that was clear. Another function, which is while loop. So that's also an interesting function that will check all the time when it goes through the loop if a certain condition is true still. So, you know, just very schematically, it would be something like while something is true, while something is true, run this code. I don't know if I have an example of that here. It's a code that we won't be needing immediately. So I'm going to skip that for the moment because it's going to be too much saturation for you guys. Okay. We'll also do a short break so you're not get saturated. Okay. We'll go a bit into functions. So functions, let's call it custom functions. So you can make your own function. Let's say you have something that you need a lot in your coding, and it's not available in NumPy or in any other thing. So you can make your own custom definition of a function. So the way you do that, let's make a definition. So def, you see the color goes to blue, and I say add a comma b colon, very important, and I call this my sum is a plus b, return my sum. So what does this do? So you say I'm going to define my own function, so use def. Then this, whatever you type here, is just a name that I invented, which will be in bold. So this is your custom function name. And it has as an input a and b. So when I call this function, later when I define it, I will have to give two inputs. Then it does a calculation. In this case, it sums up a plus b. And as an output, it returns my sum, which is the sum of a and b. Okay, so let's hit it. Okay, so that's now, it doesn't give any output, right? It just defines the function. And now I can use it. So I say add 1, 3, enter. Output is 4. Okay, so I made a function that's called add, and I give some input, 1 and 3. So 1 will be a, 3 will be b. So my sum will be 4, and I return as an output 4. Okay, if I say add 10 and 12, 22. Okay, so that works. Of course, I can just use a plus sign. So it's not a very useful function, but it's just to show you what it can do. Let's do a slightly more complicated one. So let's say define add and subtract a comma b. Okay, colon, very important. So I'm going to make a function that takes two numbers, it adds them and it subtracts them, and it gives that as the output. So I say again, my sum, a plus b, my difference is a minus b, and return a tuple which has my sum and my difference. Okay, pop. Okay, so I made a function with this name. So if I want to use it, I call this name, which has two inputs, a and b. Then inside my function, I take the sum of a and b and the difference of a and b. And as an output, so return, I make a tuple with round brackets, and it has my sum and my diff. So let's use it. Add and sub, whatever, 5, 8, enter, and it gives me a tuple, 5 plus 8, and 5 minus 8. So it gives you this tuple back as an output. Okay. Let's do one more. I define a function that I call modify. And as an input, I have list. Okay, maybe I should call it list x. And I say list x index 0. So the first value times equals to 10. That means take the first number in this list, which I call list x, and multiply that number by 10. So let's take, for example, modify, and I take one of my old lists. Let's take numbers, which is this one, right? So it was this my original list. And I hit enter. And now I look at my list, and you see that the first value now went from 12 to 120. Okay, I think it's time for a break. Let's do 5 minutes, 10 minutes. It's up to you guys. Maybe 5 minutes. Put a little countdown timer. Okay. Pause this. So let's continue a couple more functions, and then we'll go to NumPy, and then we'll go to a little bit easier part on like introduction to making some plots, and then we can finish a bit early, I hope, for today. Okay, so we were looking at different functions. So let's look at a little bit more complex functions. So example of more complex function. So we'll make a function, define, def. We're going to call it intersect. And we're going to get two inputs, S1 and S2, colon, very important. And we're going to make a result, which initially is empty. So if you just type a list that is empty, it will kind of make that variable as a list, but it has no numbers in it yet. So it's an empty list, which I'm calling result, short res. And I'm going to make a for loop inside this function. So I'm going to say for value x in S1, colon. So it says for each value in this list S1, I'm going to do something. And this something is if x is in S2, I'm going to append it to the result. Okay, let's walk through that code. I'm going to, so one, that's the case. At this height, I'm going to say return res. Okay, bit complicated, right? So I'm going to look. Let's say I have two lists, S1 and 2, and I want to know which numbers are both in S1 and S2, so which numbers are intersecting. I make my empty result, and I say for each number in S1, if that number x is in S2, then you put it at the end of the result, that value. So x propagates here, and then as an output, I do result 1. So for example, I now say intersect. I'm going to put a list, 1, 2, 3, 4, 5, comma, put a space so you can see it better, 3, 4, 5, 6, 7. So look carefully at all these brackets. So I have round brackets to define what goes into the function, and I have square brackets because those are lists. Okay, so I have these two lists. I hit enter, and it gives me output 3, 4, 5. Because let's go at this level and look what it does, right? So it says, I define a function, empty result, and now it says for x in S1. So this is S1, the first list. And for X, so it takes the first value for 1. If 1 is in S2, it checks. No, it's not there. So pop, it skips, it goes back. 2. For 2, number 2, right? For the second one in S1, so it's 2. If 2 is in S2, which it's not, nothing. Okay, now the first value comes 3. If 3 is in S2, yes, it is. Okay, append 3 to result. And then it does the same for 4 and 5, which are also in S2. And it returns S3, the result, which is 3, 4, 5. Okay, so this is very useful to use your own homemade functions that you can store. So that once you are defined, they are available in your entire workspace. So if you use, for example, that in a script, you can build more complicated modules by defining your own function and then building on that. Okay, NumPy. So this is a super useful library for anything that we are going to do. And so to import it, I already told you before, import NumPy as NP. And it's kind of convention, right? So everyone that basically uses NumPy, it imports it as NP. So if you Google things on help on NumPy, you will often see NP something, which is basically NumPy. So the same goes for other libraries. They're usually imported as an abbreviation which everyone uses, but you can use whatever you want. Again, if you want to say import NumPy as puppy dog, then for every function you have to do puppy dog dot and then the function. But for simplicity, you want to take something as short as possible, like NP. Let's look at vectors, for example. If I want to make a vector with all zeros, so I'm going to call it 0 vector. And we say NP, so NumPy dot zeros 5. So it actually, when you hit the bracket, right, it pops up and it gives you some information on the input that it's expecting, right? So this is the shape. So if I just type 5, it will just make a linear array. Right, let's look where it is. 0 vector. It's an array of float 64. So this float 64 is, again, it's a number with a lot of precision. So you see like 0 dot, 0 dot, 0 dot, 0 dot, 0 dot. I mean, why do you have this 0 here? Because it's a floating number. So even though it's 0, this is a way to indicate that it has more digits potentially behind the comma. Versus if you go to a list, this is a list of integers, right? So it's 2, 2, 6, so these are integer numbers. Okay. You can also make matrices. So for example, 0 matrix, same function, np.zeros. But now we're going to give as an input, we're going to give a tuple. So for example, 5, 3. It will make a matrix. Okay, it's a bit difficult to see, which I think you can even double click this. You see it has 3 columns and 5 rows, which are all 0. So if you double click on that, I hope you can actually see that in my share. You can double click a value in your variable list and it will pop out and it will give you the whole matrix to see. Okay, so it's 3 columns, 5 rows. Okay, so Now let's go to a matrix with some actual numbers in it. So let's make a matrix. We call it, let's call it Z. And we say np.array. And as an input, we're going to give a list 1, 2, 3. Okay, so I have an array of integers here with a lot of numerical precision. So it can be a very huge integer. Okay, so 1, 2, 3. And you can, if you want to make multiple rows, you can make bigger ones. So let's say A is np.array. And I take my first list. Let's say 1, 3, comma, 5, 9, round brackets. Okay, oops, sorry. You need actually double brackets. So hop. Okay, so you need to put a list, comma, another list, which is itself a list, which goes into np array. And once you do that, we have an array which has 1, 3, and 5, 9. Okay, so once you have a matrix, you can do things like transposing the matrix, which is mathematically very much used, right? So you do a dot transpose. And so I transposed the matrix. So now we have 1, 5, 3, 9. Right? Versus the original was 1, 3, 5, 9. Okay, so that's transposing. If you want to take, for example, a row or a column out of a matrix, you can do that. So if you say I'll explain what this does. Right? Let's see what it gets. So this means A, and then if I put a colon in a list, it means all. So it says I take, so the first one is row, column, right? So I take all values of all rows of the second column, because 0 is the first column, 1 is the second column. Again, Python, the indices start at 0, which always confuses me. So as an output, I get an array, which is 3, 9. So the second column. Okay. If I, for example, want to extract the first row of this matrix, I would do A 0, because it's the first, comma, colon, which means all, right? I hit that and I get 1, 3. So I get the first row of my matrix out. Okay, so once we have a matrix, and we'll get back, like in the beginning, I told you, if you add, for example, 2 lists, they are what's called concatenated. So they are added together. If we do a summation of 2 times the same matrix, so let's say B equals A plus A, and we look at B, we get, like you expect, an element-wise addition. So 1 plus 1 gives 2, 3 plus 3 gives 6, 5 plus 5 gives 10, 9 plus 9 gives 18. Right? So you get an element-wise addition of your matrix. Let's say we want to make an array which is B, all rows, first column, plus A, all rows, comma, 0, which is first column. So I'm taking the first column of B and the first column of A, and then C, I get 315. Okay. Something we are going to use a lot, it's called linspace, or the second one is log space. And it's basically a way to make a range of numbers, but it doesn't need to be integer numbers. It can be float, so many digits behind the comma. So for example, I say np.linspace 0,100. So it tells you start value, stop value, and then the number of points, which by default is apparently 50, but let's say we put 11. And then we look, and then we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. They all have a period behind it to indicate that it's a floating number, right? But you can put as many numbers as you want, and it doesn't have to be integer. So if we put, for example, 20, it will be more ugly, right? Then you have 0, 5.26, 10.52. You know, so let's say you are trying to make an x-axis for a plot, or you have, let's say you want to plot a linear function. You want to first make a linspace of the values that you want to use as input, and then maybe use a function to calculate the y values, and then you can plot it. So linspace is a way to make an equally spaced, linearly spaced array of values. The same thing goes for log space. So there's numpy log space. You start, so this is now 10 to the power 1, 2, that's the end. So it would go from 1 to 100 with, let's say, 10 values. So it starts 10, so 10 to the power 1, and it goes to 10 to the power 2, which is 100. That's the last number, in 10 steps, right? So you have 10, 12, 16.68, and so on and so on. So you can make an equally spaced, but in a logarithmic space array, which can be useful. Let's say you want to make a log plot of something. You want to have equally spaced points in your log plot. You can better use log space than linspace, right? Because if you do linspace, y0 120, which shows it's not in the list. I don't exactly understand this question. Okay, so why is it not integer? Okay, so for that, because we would have to put, I guess, so if you take linspace, yeah, it's because, okay, I'll show you. So linspace, go back to this one, 0, 120. So why is this not integer? Because if I put 21, now it's integer, it's more or less integer, because it always has one value more, right? Because of this way of having the lists, which is always one more than you think, because the index starts at 0. So if you say, if you want to get the integer list, then you have to add 1 here. But it, you know, if you have a continuous function, then you don't care, right? Your input doesn't have to be integer. If I plot y equals 2 times x, it's defined for all values. So if I have a non-integer spacing on my linspace, it doesn't really matter. Maybe to make a nicer plot, you can put integer numbers, but linear space, same difference. Right, so linspace chops your range up from 0 to 100 up into equal parts. So if I put 21, because we start at 0, then it's 5, right? 5, 10, 15, 20. But let's say you want to make a plot, you might want to put a lot of values. So you can take 201, then the spacing will be half. Just depends, let's say you're generating a plot, how many points, data points do you want to get on your line? If you use linspace, it's very easy to get thousands of points on your line, so you get a very smooth line. Okay, let's see, we were going through that. Also, the last couple of useful things. So if you want to get the size of a matrix, you can read it off in the variable explorer, or you can just say a.shape, and it will give you 2 by 2, right? The same as in the thing. Or you can say a.size. So that gives you the total number of elements in the matrix. So its shape gives you this, the rows and the columns, and size gives you the total number of values in there. Okay, I think that is good for now. Let's go to some plotting. Okay, sorry, can you repeat the meaning for the log space function? Right. So log space, np.log space. It's, let's say you want to do a Lineweaver Berg plot. I don't know, maybe not the best example, or Arrhenius plot or something. So you want to have, maybe on the x-axis, you want to get a log scale. If you do a linear sampling as an input, right, then on a log scale you will have many points at the beginning and almost no points at the end. Whereas if you do log space, it will make an equal spacing on a logarithmic scale. Okay, maybe later we can do a little plot to see what that looks like. But if I do log space 1 to, let's say, 10,000 with 101 points, okay, maybe that was not exactly right. I will start at 10, and I will make an array which is logarithmically spaced to 10,000. It's just a way that if you are plotting a function on a log scale, it's nicer to have as an input a logarithmic array than a linear array. Okay, this kind of will make sense once you start making your own code, and you will just look at the graph and see, oh, all my points are at the beginning because I'm using logarithmic scale and I have a linear array to use as an input. Okay. matplotlib. Okay, so this is, let's say, the most used library to make plots, and so it's a bit I find it a bit non-trivial to make plots in Python, but let's see if we can learn the basics. And you'll see that once you have gone through making an entire script with plotting, you will just reuse your own code and copy paste it around, but it's just the first time it's a bit annoying. Okay, so we're going to say import matplotlib.pyplot, which is a very long name, as plt. Okay, so we're importing this library, which is called like this. We don't know why, but that's it, and we're going to rename it as plt. Okay, let's see what we can do. For example, plt.plot. So now I've renamed it to plt, right? So now I can just call plt.plot. So plot is a function in the matplotlib.pyplot library, which we are renaming as plt. And I'm going to just make a list 0, 1, 4, 9, 60. Up. I don't know if you can actually see this pop up. Do you see a graph?
No.
Maybe not.
No, we can see it.
Yeah, it's okay. What I should do. 1 second, I disconnect my display. 1 second.
In plus, it appeared in variable next to variable explorer. You can see.
Let me, because I have this big screen and it's a bit annoying. Let me share my entire screen, then you can see it. Wait, desktop. Okay, so now, no, here it is. Okay, so in some cases, if you're just using your Python new, it might give you the plot inline, so it would give you the plot here. So you can either see it. Well, I don't see it here, but it depends a bit on your settings. So if you go in the preferences, kind of always forget where it is. There's this thing called IPython console, and in graphics, it shows you where a plot is automatically displayed. So for me, it's set to automatic, but so it might be on inline in your version. And then it plots it in your code, which is kind of annoying. So it's, for me, it works on automatic, but otherwise you can take one of these Qt5 or Qt4 that could work for your version. So once you have that plot, yep, there we go. We didn't actually specify any, let's say any Y or X axis. We just gave some random values, right? So it put 0, 1, 4, 9, and 16, and it just plots that at the integer interval, right? So 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. Okay. And then this plot, you can save it as a figure, as a PNG. So that's a nice way to export your plot. Okay, we'll see more things we can do with that. Okay, so sometimes maybe your plot doesn't show up. So you can do plt.show. And okay, now I didn't have this plot, but okay. So in my case, it just comes up automatically. But if it doesn't, you can use plt.show. Okay. So I now say an example. Okay. So I'm going to show you an example now. So when you start, okay, I think we went enough through all the basic functions. So once you know those, you want to probably start working in the scripting environment. So this is on the left side typically, or if it's not showing, you can probably hide or unhide that layout. Okay, there are different ways of layouts. So if you're used to MATLAB, you can choose the MATLAB layout, but I guess we use the default layout, which is like that. Okay. So then you can start writing all these things that we've been doing before in your example, right? So for example, import matplotlib, it recognizes it, lib, oops, .py plot as plt, and import numpy as np, and then you will see later there might be other ones. And then this you can just save as a file, right? So let's say test or something, test1, and the default extension is python.py. You save it, and then the next time you want to do some script, you just copy this stuff to your new script, and you'll see that there are, let's say, 4 or 5 libraries that we keep on using and using and using. So you can just copy paste those things out, and you don't have to do that anymore. So let's maybe do a very simple example, and we'll just plot some equation, right? So we say, okay, this we can leave. The author you can also leave. And we're going to say solve simple equation y equals 2 times x to the power 2. That's the equation we're going to solve. And we're going to go to the comment, make a linear array for x values. Okay, so for example, I say x equals numpy dot linspace 0 to 10, 101 points. We get a nice equal distribution. And I'm going to just do the very simpler, we'll get back to this. Calculate y values. Okay, so the simplest way, call it y simple, is just take that. So this is now a vector, right? X is a vector. 2 times x to the power 2, right? So let me space it out for you so you see it. So 2 asterisks is times x to the power 2. Remember, I have to put 2 asterisks. Okay, so if we do that, I'm first going to clear all here, reset, yes. I'm just clearing up my variables, so I have an empty thing. So let's see if we run this code. You just click this green plus button here at the top, and it will run the entire script. And there's a little orange warning here, and it says matplotlib is imported, but it's not used because we still didn't use it. We're going to use it now. But if you look at this x, so it's an array of floating point numbers. Again, if you double click here, it will give you all the numbers with a nice color scale. So it goes from 0 to 10 in 100 points. And so that's my x values, and y is then calculated. Up 0, and it goes to 200 logically. Okay, so how do we plot that? Let's say simple plot. Okay, this last thing, then we finish. Sorry, I'm taking too long. So first, we want to make a new empty figure. So plt.figure. Okay. Up. Oops. And then we say plt.plot x, y. Let's see what that looks like. Okay, this is really the very simplest thing we can do. I save the script, Control S or Command S on Mac. Play. Oh, and y is not defined. Okay, so this is always very useful, the error. It will tell you where you screwed up, right? So it says in your file, this is our file, on line 22, it goes wrong here and it puts a little X here. So here we screwed up. Why? Because I put Y and I called it y simple. Okay, so I should put y simple. Okay, yeah, it knows that one. So if you double click, if you select, for example, a name, everywhere in your code, it will highlight in yellow where that appears. Okay, so I save it. There's a little asterisk, which means it's unsaved now. If I do Control S, it's saved. I run it, green play button, boom. And it gets you your line, which is smooth. So by default, it takes a smooth line. If you want to see the actual data points, you can define, we'll come back to this in the next class, the style of plotting. So for example, if I do like this, you will see all the data points as circles. There are still a lot of data points, so that's why it still looks smooth. If we reduce the number of points on X, let's say we go back to 11, then now you see